I'd like to welcome everyone to this wonderful mini webinar here. It's about a very important topic related to IoT. Everything has its challenges, and every new trend, every new technology always face challenges, and challenges create new ideas and create new companies and create new new trends, and this is what we're going to explore today. So in 30 minutes, I'm going to go over the challenges, and hopefully in the Chicago webinar or Chicago seminar here we'll talk more about that. Okay, this is a little bit about myself, and thanks for the introduction. This is the same thing you heard about it. It's just to make to give everybody an idea about my background. My interest in IoT started in 2014, and it was out of a small project I did with another university, and here comes the term IoT, Internet of Things. Giving the credit to Cisco for starting this term of Internet of Things. It's not a new thing. It's actually been there for many years. It's just now it's become a reality. Cisco named it Internet of Everything, and then the term Internet of Things has become more common and make more sense when we talk about Internet of Things. So let's dive into the concept here. Internet of Things have three major challenges, namely the technology, business, and society. And this is not just for a specific or related to Internet of Things. There are actually every new trend you will see, you create, have to overcome three main key obstacles, challenges: technology, business, society. I'll give you a small example that will clarify this. Do I have the technology to create it? For example, flying cars, we see from time to time some kind of a prototype for that one. We don't have that technology that will create it in a mass production. Business, what's in it for me? I have money, I'm interested, I'm a venture capitalist, I am somebody who loves technology, I would like to invest in new trends, I would like to be ahead of the curve. Do I have some kind of a return on investment here? What's in it for me as a business? The third one is society, which is the difficult one here, because society has two branches, the government and the citizens. Any problems with implementing this technology or this new trend? Any resistance from the society for something like this? And the prime example of one of the things out of the Internet of Things that really faced some issues here, Google Glasses. Technology is there, they have it. Business, they open it for everybody. Yeah, not everybody got the glasses, it's expensive, and there's some problem. When it starts going to the third filter, which is society, it's actually failed. Because I don't want to sit with somebody and he or she is wearing those glasses and looking at me and trying to check my Facebook and check my Twitter feed and talking to them while he or she is talking to me. So they modify the business model so the society will accept it. They have it related to professions like dentists, doctors, HR, and it was accepted by the society, it was accepted by the government. So have this framework in mind when we talk about the Internet of Things. So that's going to clarify to us why the spread and the adoption of the Internet of Things sometimes is slowed down, sometimes is actually expanding. This diagram is the size itself means nothing. It's just the sequence and the movement of the gears here. So let's start with technology. If you look at the technology here, you're going to see that we have 5 challenges. First one is security. I'm going to go over each one of them very quickly: connectivity, compatibility, longevity, standards, and intelligent analysis and actions. So this is from the perspective of technical challenges. I have to overcome all of this so I can go to the next level, which is the business, and then go to the next level, which is the society. Security is a big thing, and everybody knows this one, and we live in an area or an era where security is a big concern for us. You've been watched, and every step you make, every move you take, every breath you take, you've been watched here. Whether it's by your phone, whether it's by your laptop, it's a matter of you are connected to the internet. There is an issue of security here. And it's really creating a larger scale because of the number of the devices connected. So we can have this X factor when it comes to security. Many nodes added to the internet, and that's part of the system of our system, which is the Internet of Things, and that's created a problem, and that's created security holes, and that's created possibilities for hackers to get in and to steal and to modify and to change direction of certain events. So security is one of the biggest challenges, and this is one of the questions people ask: is this secure? I mean, what should I give so I can get this technology out of my security? A big example, and I lived that one, second by second. I was giving a speech in Santa Clara, California, and that speech was about security. And the person before me was actually from Homeland Security, so I was giving the next speech. And that time, Friday, October 21st of 2016, there was a massive distributed denial of service by a simple code waiting in C, available in GitHub. You can look at that code. It's disabled, but you can look at that, the lines. You can read. It's a very simple one, and that attack brought down 500 million devices. And the only reason for that code to work, and by the way, the name of that code is Mariah, which is the Japanese word for future. The only reason for that one is because those devices, or these devices, they kept the default security password. So the password which came with the factory, it's the same. They didn't change it. See, I think I have some. Okay, I will go over the questions after I finish the presentation. Please, you can type, you can type all your questions, and I will read them. And also, if I couldn't answer them today, I will be more than happy to reply to you by email. So that's another thing. The other one is the connectivity. Now the model we're talking about here, which is of the IoT, is basically you're talking about client server, single point of failure system where everything has to go to a centralized location to make a decision about it, even if that action you need is next to you. You have to go back to the center and come back and make that decision, and that's fine with the current system. But when you're talking about billions and of devices, Gartner, they say that about 20 billion by 2020. Cisco is saying about 50 billion by 2020 devices that connected. Now we're talking about a different model. We need a different model to do that. One solution for connectivity is something called a fog computing. And fog computing itself is a fascinating concept, which means you are distributing the responsibilities and the decision making to the nodes close to the action. So if that action is a simple action or something can be done locally, you finish it. You don't have to come back to the centralized, to the cloud, and ask for permission or ask for decision, and then come back to the node which is about 3 feet or 2 meters away from you. So fog computing is even in 2018. I just submitted my paper to IEEE about the predictions for 2018. One of the major prediction for IoT is the visibility of fog computer, or sometimes they call it edge computing, which is you give more processing power to the devices at the edge, devices close to the action. This is good for things like driverless cars, like autonomous cars, where they don't have to go back and forth. I mean, they don't have time for that. And fractions of a second means death and life for them. For the drivers, and it means a lot for the companies like Tesla and so on. And Tesla is complaining about that. They're complaining big time about uploading the information and then getting the answer of this one. They don't have this luxury of having to wait for the centralized or the cloud to give them the next move here. This model have its own challenges, especially from security perspective, but blockchain is another answer for that. You're welcome to check, the blog about blockchain here. I wrote like 3 or 4 of them talking about what is blockchain, how is that related to IoT, and what does that mean. In a simple example, blockchain, just to understand the difference between the current system for security and the blockchain model. Currently, if the network of the internet is a building with 100 people inside it, and there is a security guard at the door, check the badges, confirm the identity of people. Once they get in, they're part of the network. There's a problem with this because I can fool, I can forge, I can bribe that security guard, he or she. But if you're talking about blockchain, I will assign, let's say 80% of the people in that building to be some kind of security guards, where any new faces we see in the building, they have to confirm that they're okay, and they have to communicate with other nodes. So if that person get in, then the first node will say, yeah, this person is okay, this person is okay. Until I hit the 80, percent, or the 80 as a parameter here, then that person will be part of the building. So I cannot fool 80. I cannot, bribe 80 people, but I can do it with one person, standing. So this is the difference between the two, with the two system in a very simple way here. Compatibility and longevity. Compatibility is a big thing because we are, and you're going to see this one in coming slides. Standardization is one of the biggest obstacles for the spread of IoT. I hope, and I hope that will happen soon, where I can go and buy any device for IoT and just plug it and it's play right away. Now, if you think about the big names, Google, Amazon, you're talking about Apple, you're talking about IBM, you're talking about SAP, all of them, they have their own IoT hub. Siri is the hub for Apple. Google Home is the hub for Google. And you're talking about Watson is the hub for. And they want everything connected to that. And they want you to be part of that ecosystem. Now we got a problem because there can different hubs, different operating system, different way of communication. We got a problem with that. So compatibility is the thing that hopefully that we're going to get to the stage where I don't care from where I get that devices, whether I have Alexa from Amazon, whether I have Siri from Apple, I can just connect it to that hub and it's going to work. Now I'm talking to everybody here and I'm looking at my, desktop. I'm looking at my monitor is from Gateway. My speakers are from some weird company there, and my keyboard is from Dell, and my computer is from HP, and they're working perfectly because there is an operating system that understands the different drivers and get them connected. This is what we are looking for here. The other thing is that the longevity here. The longevity of the thing about devices will be obsolete, will be upgrades, there will be a new devices, and you look at the ecosystem or the connectivity of all the devices of IoT, they're not the same age. They are not the same capabilities there. And you have to deal with that. Some of them, with the back technology, with the future technology, with a challenge, with the technical, challenges that instead of dealing with 10,000, you're dealing now with billions of them. Some of these technology will eventually become obsolete, and this is the issue with that. Standards. This is exactly what we're talking about when we talk about the standards in this case. The standards themselves has some issues here. Technology standard, which include the network protocols, communication protocols, data aggregation standards. They're all some of activities. The handling, processing, storing data and collected from the different sensors. This volume of data is increasing in a very scary rate, and with this scale, scope, and frequency of collecting this data. And the reason for this one is because the sources of the data is expanding. The sources of the data is increasing by the second. So when we talk about the standards, now you have to have a standard that will help in dealing with this kind of expansion here. Challenges facing the adoption of these standards within the IoT, structured data and unstructured data. Dealing with, I know sometimes we call it dark data, how to deal with that. The other thing, that technical skills is a big thing. I look at this one as one of the challenging parts. We ask many of the CEOs of the company, they say, we have a shortage of talents when it comes to IoT. People who, and IoT is a big word, okay? I need somebody who knows about data science, for example. A data scientist will help us in this. Shortage at every level, what's the hardware or the software. And until now, we don't have that unified programs at university. They have classes, they have courses right and left, they have short certificates that they can give it to you at the top of your knowledge so we can deal with the IoT there. But until we get to the point where there are really a solid education for that one, companies, what they do this one internally. I know that Airbnb, they did that. They started their own internal program to deal with the expansion of Internet of Things. The last one is the intelligent analysis and action. Data is data. It's the same thing. And data is the new oil. And we have to keep this in mind when we talk about, about IoT. That's the whole thing. That is the soul of the Internet of Things. We have all these devices, hardware, but the most important thing of it is getting this data. Now, how can we deal with this data is the big question in an intelligent analysis and intelligent actions at the same time. It's the last stage, implementation, extracting this data, giving you some kind of insight, and this insight will be, we'll use cognitive technologies and analyze it and give you some kind of visualization of the data so you can make that decision. The artificial intelligence is a big thing, and I'm going to pause here for a second before I go to the next slide here. There are two branches in IoT that is really under heavy investments: security and analytics. Security is you can summarize this one around the blockchain, technologies that a lot of companies, they're trying to push it so it can secure the IoT. The analytics is under the umbrella of the artificial intelligence, and it's one of the hottest areas in IoT. How can I use AI and improve my insight for this non-stop stream of data? I mean, this is a big challenge, and that's why in another lecture I did it early this morning, is talking about how the artificial intelligence is the catalyst for the Internet of Things. Or in simple word, is the Internet of Things is the muscles, and the artificial intelligence is the brain. You can have a beautiful body, strong, no brain means nothing. You need that brain for that. The driving forces for the adoption of the intelligent analytics within the IoT, real-time data processing, very good. Tools like the complex event processing, or near real-time basis analysis. That's a big drive for that. Challenges for using artificial intelligence here is inaccurate, which is the bad data. 80% of the time spent by the data scientists is to clean the data. There was a study done about how much time they spend to prepare the data itself so it can go to the analysis. 80% of the time of the data scientists spent on cleaning the data so they can go to the next one. And like what, 10%, 15% for the modeling, for the testing, and the other 5% for making sure to check that everything's okay. So presence of outliers is a problem. False, information, redundancy, all of these things has to be cleaned. And the other one is legacy system ability to analyze unstructured data. Again, back to that picture about you're dealing with different systems, different ages, different capabilities, and that's a challenge because the old system, they're not powerful enough to deal with real-time data. Now you have to do something about balancing that one. So if I'm receiving the data from multiple systems, and one of them is a legacy system, an old system, use old computers or old technology, and I receive another data coming from a new one, it's up to date. Now how can I balance this act? How can I make sure that I'm, by the end of the day, the person on the other side will receive the data on time, in the correct format, with the correct speed, and the correct data. The driving force for the adoption of the analytics in IoT, which is helping us, is the prices for the machines are very, very cheap. The functionality of the machines, you're talking about graphical processing units from companies like NVIDIA, they are tremendously strong. Your phone, your smartphone is as powerful as a whole disk top computer. They have the same capabilities, and the machine influence human action through behavioral science rational. That's the thing about it, which is training those machines to act like human, and deep learning tools that will make the machines will make Siri understand your lifestyle and recommend something that will fit within your profile. Will make Alexa anticipate what is missing in the house and telling you that you're missing this and this. That's part of the story of the deep learning. And one thing before I go to the next slide is I have some of my questions. One of my students asking me what is this difference? What are the differences between machine learning and deep learning and artificial intelligence? Well, I give them a simple example. Tell them, okay, machine learning is this. If you feed the computer with that machine learning algorithm, which is a code that you can build yourself, and you feed that computer with 100 pictures of people, and you tell the computer, I want you to scan the pictures and get the picture of people smiling. Now, out of the 100, let's say there is 30 of them. The computer will scan all the images, and then with a certain definition in the code saying if the lips are in a certain way opened and the eyes and things like this one, then they will take that 20, let's say 30 pictures. This is people smiling. This is artificial. This is machine learning. Deep learning is the next step. Why they are smiling? Is it a real smile? Is it a fear, smiling out of fear? Is it a defense mechanism smile? That is deep learning. So this is and artificial intelligence is covering both, asking for the machine learning and the deep learning at the same time. We got a problem with this one from the challenges, facing the adoptions of the artificial intelligence or the intelligent analysis in in IoT, machine actions in some kind of unpredictable situation. Prime example of this one, you have a car, autonomous car, driverless car, and you have one person and you have a group of people, and you have no chance. You have to hit one. So which one? Based on what? Now we come to that issue, and information security. Machine interoperability here, mean revert human behavior, which is don't understand what does that mean. Sometimes I'll say a word and I mean something else with that one, and slow adoption of new technology because of many factors here. So that will take care of the technology. Let's talk about the business. Money is the bottom line here. I'll have $1 million and I'm expecting 10, 50, 100 in return. That's the key thing. So if there is a return here, I'll take it. And to understand this one here, look at the 3 categories of IoT. I mean, I can say that commercial and industrial are the same, but just to make sure that we are on the same page, let's define each one of them. The consumer IoT is, smart, phones, smart watches, laptop, anything connected that the consumer can use. The commercial one is inventory control devices, tracking, and medical connected devices. The industrial one, which is the big one, covers such things as, electrical meters, waters, gadgets for the flow control, pipelines, anything has to do with the industrial application there. The last one is the society challenges. Understanding IoT from the customer and the regulator perspective is not an easy thing because you have so many factors with that. Customer demands keep changing. You want to make this big, make this small. New users for the devices. You have your smartphone. Your smartphone is not used just only for text or for app. There are so many applications. It's an access point here. Though this kind of understanding is really important to deal with the last obstacle here, and it's really expanding here. At the top of this one, you have the consumer confidence. Talking about prevent IoT from fulfilling the potential, which means I'm expecting more. I'm expecting more from the device. I'm expecting more from the from this gadget I have here. And the lack of understanding and education by the consumer by simply changing the default password for the device. I'm not talking about the smartphone. I'm talking about things like Nest thermostat. The Nest thermostat, people just keep it with the default and don't change that one. If you have anything that is a smart device, the first thing you should do is change the password for there. And this will show you how it's really, how the relationship between the data you have that the IoT collected and how the technology for security will protect that one. At the top of this one, the business and the policies and the procedures which is imposed by the company, and also this is within the environment of the laws and regulation to protect us. I mean, Europe, they're going through some regulation that will protect protect the data and for the consumers. We don't have this in the United States. They're still behind when it comes to privacy, when it comes to security and protecting the consumer's information. Last one is privacy. Privacy, it's a big thing. Well, I need it to be fast, but I need it to be secure. I need it to be private. Privacy is a big thing. And this is another challenge. How can I confirm and make sure that the consumer is really feeling comfortable giving me his information, and I keep that information and I protect that information? And if you look around, you're going to see many devices that tracking you, sending the information back to, to big companies, collecting this information, analyzing this information. You drive by a store, you're going to find a notification on your smartphone saying there is a discount here. It's becoming more, prevalent for the devices, with their tracking capabilities here. In order for us to realize the whole opportunity of IoT, we need some strategies, and those strategies has to confirm privacy, safety, and security for the consumer, so we can overcome the last leg of the of the challenges here. And then comes the government, the standard, the regulatory standards for the data market, who own it, for how long, how can they share it. I mean, that famous term, we only share your information with a trusted third party, means everybody. So when you talk about this one, that's going to be a problem here. How can I opt out and opt in from this? We need to keep this in mind when we talk about this. Okay, I think I am within the time frame here. I don't want to take more time with that. Okay, it's because I think that's okay. So let's see. I think I have what? Do I have? Let me see. Do I have time to answer those questions, or I can just take them and email that to them? Okay, let me get this. So I think I have a few questions here. I'm reading the question here. For IoT to be successful for businesses, purpose of the ecosystem will be banned all, okay, the manufacturer services. That is true. It was expected to forecasting. What is preventing this from happening? Oh, that's a very good question about what's preventing. It's money. It's money. What will make Apple, Google, Amazon, IBM, SAP, you name the companies, to get together and say we're going to have a unified standard for all the three, the business, the technology, and the society? It's a market share. Until they get something bigger than what they have now as a market share, or the government impose something like that, we're not going to do business with you unless you are really, all of you are really having, sharing the same standards, like the ISO 9000, for example. Then we're not going to accomplish anything. So that's part of the standards here. Everyone agrees IoT is essential place to our future, but why the adoption is very slow even with the experiment? Okay, I answered that one in my presentation. It's all back again to the three obstacles: the availability of the technology, the business model for it, and the society. How to overcome the fear of policy of policing of the customers. Then they have some rules and regulation, like what happened in Europe when I join, when I buy, when I sign in, I know that my data is protected. There are many standards. That is correct. An initiative out there. Which specific standards are missing? All of them. There are no unifying standards. I mean, if you look at an organization like IEEE, which is a leading organization when it comes to something like this, they only have 4 standards for IoT. And that's really sad, because if you look at the IEEE 802.xx, which is the one used for the wireless, you have about 4,000. So when you talk about this is really big for them. Okay. Do you think IoT will have a future in countries with well, I mean, that's a problem. They have to answer those questions. And again, if we are not on the same page of overcoming the challenges here, especially the last one for the society, and for the which include the government and the citizen, then it doesn't matter what kind of technology or business model here, it's going to be rejected, and that's the problem. Okay. Okay, perfect. I think I'm over the time here by 3 minutes. I apologize for that. So thank you so much for your time.
Thank you, Mr. Banafa, for your time and a great presentation.